Good morning. I am Dr. Chinmay Kumar Sahu. I am going to show you about the indexing mechanism. So let's go for this is my content of the presentation. First of all, we should know where we are going to use the indexing. We know that for manufacturing gear, we have to choose gear. We have to cut the tooth of the gear such that the distance between the two teeth should remain constant, and that should be firmly placed. For manufacturing this gear, this term is known as the pitch, which should be always remain constant. But how we are can go for it? So that means how we can make this gear, this pitch constant. The thing is that for the one of the simple method is that use of indexing mechanism or indexing head. One of the famous method of the cutting the teeth of the gear is the milling. Another one is the shaping. In the both type of method, we can use the indexing head. So how indexing head is look like is better that we can watch over this. This is known as the indexing head. So here what are the these two are the dead center. These are two are the center to hold the job. This is the job. What will happen? So when job is hold and we use a cutter. Normally this is a milling cutter and this is only present. This cutter rotate and it move along the job so that it can able to cut some material. Then what we do with the help of indexing mechanism, we have to rotate the job at a equal distance, the same as the pitch. For this rotation, we have to use this indexing crank. And for this one also we are using the index plate. But we should know how it works. So let's go for this one. This is a schematic diagram of this indexing head. So here it is the index plate. What I have shown in here, large amount of holes are there, that is known as index plate, index crank. So here worm and worm gear mechanism are there. So this is used for the high gear reduction ratio. So when we rotate this index crank at one rotation, as the gear ratio is 1:40, if we rotate it one complete rotation, the index crank, the worm will rotate and the worm gear will move in this direction. For the one complete rotation, one teeth will move. Okay, then what this means, if we have to make a 40 rotation of the crank to make a complete circle of the worm gear, our job is fitted with the worm gear, means with this center our job will be fitted. So that means that when we rotate the index crank, our job will be rotated. If we want to make the half of want to move half of the teeth, then we have to rotate half of the index crank. So this way we can go for it. We can rotate the job by rotating the index crank. So here is the worm and wormhole mechanism. These two, how it works. This is the index plate. Okay, this one is the index plate. We can observe that large amount of holes are there to proper cutting of the or proper spacing of the gear. So different type index plate are there. So famous are the brown and sharp dividing head and the lineated and percussion head. This is the plate number and number of holes present in the dividing head or plate. This should be given in your question. So in the simple indexing, what this is the formula. Number of the crank rotation required is equal to 40 by number of division required. Better that we should solve one question so that we can know it. So 40, what does it mean? Due to that gear ratio 1:40. I have already described you that for one complete rotation of the worm gear or our job, we require to rotate the crank 40 rotation. Okay, let's calculate this is the question. Calculate the index required to cut 28 gear in a workpiece by using simple indexing method. That means our number of, according to the last formula, number of rotation of the crank, this is the crank rotation, that is small n, is equal to, okay, let's use small n, is equal to, what is that? Earlier case it is written 40 by number of division required. So this is the 40 by number of division required. Let's go for 40 by number of division. What is the number of division here? 28 here. Means you have to make the workpiece into 28 equal parts. Okay, how if we divide it, then something just like it coming 1 by 3 by 7. Okay, what does it indicate? 1, this one, what does it indicate? Means one complete rotation, one complete rotation of crank of index crank plus 3 by 7 rotation of index crank. But question is that how we can go for the 3 by 7 rotation. Okay, so better to go for that. So how we can go? So let's go for another slide and we can clearly observe it. One complete rotation plus 3 by 7. So 3 by 7 means this top part is indicated the whole number and this denominator part is the circle number. Here we can observe that Brownian and Sharpe dividing head plate number is given, but here no 3 or 7 means circle number 7 is not available. Here we can find out that circle number 21 is available, anything is available. Here what it is better to do? So what we do? Just multiply the same number with the numerator and denominator. Let's multiply 3 into 3. So what will happen is one complete rotation plus 9 by 21. This means in 21 whole circle number, you have to go to the 9th whole number. 9 whole number. Okay, what does it mean? How to get it the 28 here? One complete rotation of crank plus in 21 whole circle, 21 number whole circle, 9 number whole. Means one spacing you get this after cutting one gear, you have to move one complete rotation of the crank plus this amount, so that we can go for the next gear. Okay, just like that you can completely divide it. If you repeat this process, you can get the 28 number of gear without any having the same type of pitch, without having any defect. Okay, this is the angular indexing. Sometime last time what we did say that um, number of division means 28 number of gear we are going to cut. Now sometime we can also specify if you are cutting two slot as for my angle. Okay, let first slot will be cut here, second slot will be cut here if the angle is given. So how we can do it? We can using the simple formula, number of crank rotation is equal to indexing angle required in the degree by 9. Okay, how we are going to get 9? So better you should remember this formula, but you should know how we are going to get the 9. What is the 9? So if we rotate the 40 division, 40 number of rotation of the crank, that is equal to the one complete rotation of the worm wheel or the worm gear or the job, means 360-degree rotation of job or the workpiece. That is one complete rotation means 360 by 40. In one complete rotation of your crank, your workpiece is going to move 9 degrees. Okay, such a way that we can calculate. So better to go for a one problem practice so that we can solve. Okay, here the indexing angle required is 28-degree angle. Okay, what is the formula? Number of crank rotation is equal to angle number division in angle, as for it is indexing angle required in degree, 28 degree by 9. So we can easily calculate C by 1 by 9. Okay, that means that C complete rotation of the crank plus 1 by 9 rotation of your crank. So better, as I said you earlier, so better we have to multiply something such a way that we can get the whole number and whole circle number. Below part is the whole circle number. Okay, this is the whole circle number. Upper part is the numerator is the whole number. Okay, multiply with, let's change the color of the pen. Let's multiply with the 2. Multiply with the 2. Now 3 plus 3 rotation plus 2 by 18 number of rotation. Remember that this is not plus, this is for the rotation I am giving you so that you can understand. This is the, remember, whole circle number. This is the whole number. Okay, for this degree 28-degree movement, what we have to do? 3 complete rotation of crank and in 18 whole circle to whole. So number of holes. Okay, in the index plate, whole circle and whole number are already shown. So now go for the compound indexing. So this can be betterly understood by simply if you go for and study one of the examples. Let's go for any job in 77 division. According to formula 40 by n, capital N means the crank rotation required. But 40 by 77, okay, this is not divisible. This part is the whole circle number. Okay, this is the whole number. But if you going to and watch this for total this index plate 77, or we don't have the 77, that means that we require a 77 whole circle number. Either we have to manufacture a different means whole index plate we require, or we can use the existing whole plate by using the compound indexing method. In this method, what do you do? If say this number is not available, then convert this number into two equal fractions. That is the 77 can be converted to 11 into 7. These two are the whole circle number. So in the step 3, select the whole circle based upon the number of division. Okay, so that we can available this type of whole circle. Okay, this number we use for the multiplication. Step 4, which is important. So we have to do some addition or multiplication such a way that we can maintain the 40 by 77 concept what we have used here. 40 by 77. Okay, just watch that. This concept we have to use it. 21 and 33, how we get it? Earlier step 3 it is mentioned and declared. So by using the trial and error method, if we solve this equation, we can find out that x is equal to 9, y is equal to 3. Then what the solution indicate? Solution is that indexing require 9 holes in 21 hole circle. Then we have to do a addition of the 3 holes in 33 hole circle. When we take the negative, we didn't get success, but addition we get the result through trial and error method. So I am not solving this one because this is little bit complex, and I will advise also you to avoid this type of problem. For making the simplification, we have a differential indexing. This is a very easy method because the earlier case compound indexing very complex calculation, and if some error will be happen, means your workpiece will be wasted. So what we do here, we are going to use the differential indexing. Here first of all, I will also show you the all the thing. So these are the index crank. This is the plate, indexing plate. Here we can find out that these two are connected with the bevel gear. This is the bevel gear. Okay, the bevel gear used for the power transmission in perpendicular angle. Okay, just observe that this one, when our workpiece will be connected here. Here this is the worm wheel. Okay, worm and worm wheel. So when we rotate the crank, as this crank is fitted with this bevel gear will also rotate the worm gear, and the worm gear is going to go, worm and worm gear will be rotated, and your workpiece is also going to be rotated. But at the meantime, through the bevel gear, power is also transmitted to this gear ABCD. Power will be transmitted here again. Through the bevel gear, we have to rotate the workpiece again. Means what is happening here? Workpiece is rotated directly with the help of the worm and worm gear, and through the bevel gear, through the gear arrangement. So what thing we are getting here? We are getting here that in the compound indexing, we are using two different whole circles. So that is a complex one. Here we are not going to go for the complex one. We have to choose these gears. These are the gears. Okay, these are the gears. such a way that our the workpiece will be automatically rotated, and this is a simplified process. Here is the formula. This ABCD are the gears, and this is maintaining the same formula 40 by n. So let's go and solve a problem so that we can understand. Okay, let's go. This whole description is there, so it's better that I can describe during the solving. So remember that if n prime is what is n prime, what is n, I will show you there. Okay, select a differential change gears. So spelling mistake. Gears and the index plate, and determine the number of revolution of the index crank cutting the spur gear of the 77. The same problem as earlier. N is my 77. Earlier case is a little bit complex, but let's solve it through our own process. First step 1, 77 is very difficult, so choose the step 1. As we had already tested, 40 by 77 not available of the index plate. So step 1 is that, so we have to, n is the number of division required 77, but it is not division, so select nearest value of the 77 such a way that it can be divisible by 40. So choose n prime is equal to 80. Let you can take 70, you can 80. So go for the step 2. Okay, remember that as earlier I have already explained you, if n prime is less than n, then idle gear required. If n prime is greater than n, no idle gear is required. So as n prime is greater than n, no idle gear required. So step 2, okay, choose the gear ratio. Okay, choose gear ratio such that automatically it will compensate the difference between n and n prime. Actually n is different, n prime we are selecting means we have to divide it to the 77, but it is not divisible with the 40, so we choose the 80. But there is a difference between the 3 or these two, means number 3. So how we are going to choose the gear such a way that it will compensate this difference? As stated earlier, formula is that 40 by n prime plus 1 by n A, B, C, D. The A, B, C, D are the gears teeth, okay? Teeth of the gear. Detailed description which I attach with this video in description part, so you can download it. This should satisfy this equation. Okay, for simplification, I am making this one in the simplified formula. So I am avoiding 2 steps. You can later solve it. 40 by 80 into 80 minus 77. A, B, C, D is equal to half into 3. Okay, we have 4 gears and we require the teeth of the 4 gear. So half 3, it is very complex. In our market we cannot find a gear with 1 teeth and 2 teeth, 3 teeth, but gear ratio should be maintained. So what do I do? 1 by 2 into 3 by, okay, yeah, better that, um, better that I should write it out, 6 by 2. This thing is 3. So for maintaining this gear ratio, do simple multiplication. Let multiply with 20 in by 20. Okay, this one, for this one 6 by 2. Just multiply by 10 by 10. Okay, you can change this multiplication. Where I do multiplication, I do such a way so that I can get a gear ratio. Okay, gear teeth which is available in the market. We can find a gear after 20 number of teeth and 40 number of teeth. For that, I am going to do the, okay, this is the answer. We have to choose the number of gear. A will the 20 teeth, B is equal to 60, C is equal to 40 number of teeth, D is equal to 20 number of teeth. Okay. I hope that instead of using the compound gear then you can use this type of differential indexing. Okay. Instead of the compound indexing, I'm sorry for that, you can use this one. This is very easy and effective one, and you can solve it very easily without any problem. Okay, if you have any doubt you can ask me, and I am attaching the note with this description. Thank you.